and with a deadline of 2nd January 2022. Now that is the assignment that counts towards your final mark. The assignment that you have that is due mid-November, I call it the report for your uncle, that is what we call a formative assignment. It doesn't count towards your final mark. It is there so that you will gauge your progress, so that I can comment on your report writing, because some of the questions in your exam paper will be a sort of short report or informal report. All right, so start honing your report writing skills. Now, the one that is due on the 2nd of January is what we call a summative assignment. It's called a summative assignment because the marks that you gain in that assignment will go towards your final mark. All right? Your final mark is made up of 30% of that assignment, 25% the exam that you're going to have now in December, and then 45% the final exam that you will have in June. All right? So it doesn't mean that this assignment, the one that is due in a couple of weeks' time, is not important. It is. However, it does not count towards your final grade, towards your final mark. The one that is for submission by the 2nd of January counts towards your final mark. All right, so you have to give it a lot more attention. I don't know whether you've read it already.
Not
posted it last weekend. I've already forgotten what it's about. But I let you have a read through it at the end of this session, by next session. All right, today we'll start off. If you have any questions about the assignment, we can discuss it for a couple of minutes. Okay, and then we'll carry on as usual. And that is the assignment that counts towards your final mark. Okay, clear about that?
You mentioned, sir, an exam now in December, right? By any chance, do you know the date when the exam is? Because so far we haven't received the timetable of the examinations. We just know the period.
But the timetable isn't out yet, can it? It's too early for the timetable. There are still a lot of things that are being discussed. One of the major points being discussed is whether the exam is going to be online or face-to-face. Because up till the last exams, for the last 3 or 4 sessions, I think, we had online exams. But it could be that we shift back to face-to-face exams. But it's something that is being discussed by administration, etc. And I don't know of any decisions in that sphere yet. Whatever the decision, the exam has to be handwritten. All right, your submission has to be handwritten.
That was going to be my follow-up question, because it's how can I put it? It's ironic that we are studying computing and everything, but we are basing our exams in a written manner.
I know, Kenneth, but most exams are everywhere, even University of London. Right? The exams that they hold, face exams, are handwritten. Okay, so even if it is online, so far the way that we have conducted exams was that even online you handwrite your answers, and then you scan your answers and you upload them. You can also, I mean, there's a danger with keyed in answers, right? Plagiarism.
No, fair enough.
It will be very easy for someone to find an article and copy and paste. Okay, we have plagiarism software, so it should be identified.
No, unfortunately, I asked that question in particular because the last, this is my second year, so my first year we did all the exams handwritten and uploaded them on. The
second year.
Before that, when I was studying ACCA, they actually have migrated everything over onto computer-based examinations, both theoretical and tangible. So they had structures and systems in place really to mitigate plagiarism and all that. So actually, I sent an email earlier today to the administration as a suggestion to this. So I don't know how well it would be received.
I know that there are now, the technology has given us a lot of control, a lot of power, a lot of options. But even, for example, University of London had massive problems with online examinations. This was something that was a first for us and for University of London from I think 3 terms ago, 3 semesters ago, and because of the pandemic. So it's still a learning curve even for us. And as I told you, University of London had massive problems. They had massive problems because their student base is much larger than our student base. And we had problems with a small student base. So you can imagine what problems University of London had with students all over the world. Different time zones, all right. So, but it's something that is being discussed at administration. And so, as I said, so far I haven't got any decisions that have been passed down. Obviously, you will get to know them probably at the same time as we get to know them.
No problem. Thank you, Auntie Stephanie.
All right. If I get to know anything, it hasn't been passed on to. In the meantime, I'll try and see if I can communicate it. But as I said, there are a lot of things that are still being discussed. Excuse me a minute, because I have a foreigner in my room. I have a cat. Ma fimtek?
Lex kienet naħseb kienet titkellem. Għax illum qed tkellimna fuq għad il-biċċa tax-xogħol l-istess ħaġa li kont saqsejtek jiena fuq tal-handwritten. Daqsxejn antipatika l-ħaġa, I mean fatt li tagħmel satej tikteb. Ngħid għalija jiena kif spjegajtlek irrid nibda nara kif nagħmel u nibda nikteb għax literalment ma nikteb xejn kollox fuq il-keyboard, I mean.
I know, as I was telling you.
Kienet kont nitkellmu l-lum u kont nispjegajlu dil ħaġa wkoll.
I got so used to keying in, and when I write something, I can hardly read it back because I write gibberish. My hand isn't trained any longer to write, especially if it is an lengthy piece. So I can appreciate your problems.
And it's not
anyway, let's start.
So it's not just even the element of the stamina involved that you need actually to physically train for it. Actually, not writing anything or scribbling down notes every once in a while to writing a full-on exam, 2 hours.
Yes. 2 hours, yes.
Be a nightmare.
Yes, Kenneth, I understand. Okay. But I mean that's the situation as it is at the moment, so
because that
we have to accept it. All right?
Sorry, sir.
Okay, let's start off today's lesson. Last week we spoke about information systems. We looked at information systems from 2 perspectives, from the functional perspective and the constituency perspective. And then we looked at systems that are used throughout the whole organization. And we had 3 types or 3 categories of system that we mentioned. Right, which were office information systems, or as you know them also office automation systems, collaboration and communication systems, and enterprise applications. Now, the first two categories were covered in the previous slide set. That is why enterprise applications is in red here, because this is the set that is linked to enterprise applications. And when we look at enterprise applications, these focus on integrating the key internal business processes of the organization. We try to get as many people using these systems because we need to share information. Right? And an enterprise or enterprise applications are integrated software modules, a number of modules doing different things for different parts of the organization, basically hitting all the functionality or the functions of the organization, and also hitting all the three levels of management in the organization. They are based around the common central database. That is very, very important. Unless we have a common central database, then we can't make sure that the information that we are collecting, that we are updating, is available to everybody. So when new information is entered at one point, that information is immediately available to everybody else. So all the business processes that need that information will be able to run. And we are going to have a look at 4 types of enterprise applications. First of all, the main one is an ERP, an Enterprise Resource Planning System. Now, an ERP is basically covering all the functionality of an organization. However, not all organizations need a fully fledged Enterprise Resource Planning System. So there are other systems which are also enterprise applications because they are used by most of the enterprise that may take the place of an ERP. And these are supply chain systems and customer relationship management systems, CRM. In most cases, an ERP will include a CM and CRM because an ERP will be fully fledged and it will have also functionality for customer relationship management and supplier relationship management. Now, a fourth type of enterprise application is a knowledge management system. We'll be talking about these 4 types of enterprise applications in more detail. So an ERP, first of all, will bridge the communication gap between departments. Whereas before we used to have those famous information silos where each department had its own set of information. And that information was exclusive to that department. Nowadays, we bridge that communication gap. We don't need information to be passed physically from one person to another, from one department to another. That information is available in the central database. So everybody has access to it. Data is collected from key departments and stored centrally in a single database. So that information is available to all departments. Now, some points about ERPs. Enterprise software is very complex. It is built around thousands of predefined business processes. In fact, that is why we need to run a business process re-engineering exercise before implementing an ERP. Remember when we were talking about business process re-engineering, I said that one of the times that a company undergoes a BPR exercise is before it implements an ERP. Because these predefined business processes would normally be what we call best practice processes. The large audit firms like KPMG, they do a lot of research, they do a lot of research in certain industries. And they identify the best processes within these industries. And when these ERPs are developed, they are developed by people who have a lot of experience in that particular industry. An ERP is industry specific. You will find an ERP for telecommunications, for example, but that can't be used in any other industry. It can't be used in banking. the industry is totally different. The business processes are totally different. So an ERP is industry specific. And normally it is based on best practice processes, which then requires business process re-engineering by the organization that is going to implement the ERP. ERPs are highly configurable. What is configurability? Configurability is the facility to switch on and off certain functionality. Not all organizations work the same. Excuse me. For example, to give you two very, very simple examples. In accounting, there are two ways of accounting, open item and balance forward. And they work totally different. Balance forward is when you just take the balances at the end of the period and bring them forward to the new period. With open item, any item that hasn't been paid or that hasn't been struck off will remain alive until it is paid. That is why it is an open item. Now, not all companies work on open item or not all companies work on balance forward. So the ERP software will have the actual coding to take care of both approaches. And then when you implement the ERP, the implementer will have a set of questions that he's going to ask the organization, the client. What is your accounting method, open item or balance forward? And you tick one, switch on one and switch off the other. You can't use both approaches at the same time. Right? So you use one of them. Another example would be in stock costing. Some companies use first in, first out. Some companies use standard cost. Some companies use average cost. Right? So again, the ERP will allow for each method. However, you can switch on the method that is preferable, the method that you are going to use. And that is what is known as configurability. Right? So the users will select the functions of the system that they wish to use. And then they map their business processes to the predefined business processes that are linked to these functions. Now, the other aspect, right, to configurability is customization. Customization is when we ask the software vendor to add code just for us, custom built, sort of playing around with the standard package to give us something that is tailor-made. Now, customization is not recommended as such because extensive customization may degrade system performance. And another disadvantage of customization is that it will limit future upgrade capabilities. The vendor will normally have its main line of ERP. Right? And any customizations, any particular flavors that customers want will come out of a branch. Now, obviously, the vendor is going to maintain and enhance and upgrade his main offering. So, if you have customized version 2, for example, and now the software is at version 4, you are still on version 2 with your own customization. If you want to migrate to version 4, you will need to run an exercise to see what customization has been adopted as standard in version 4. And any customization that has not been adopted as standard would need to be recustomized in version 4. For example, when we bought the billing system at Go, the addressing was based on the British way of addressing, where you have a postcode that is a particular street in an area. So if you give a postcode, the system knows that this is this street in this city, in this county. And then all you need to do was add the house number or the house name. Now, when we brought that system over to Malta, our postcodes don't work like that. I don't think they do work like that now, because initially postcodes were a postman's round. So one particular postcode in Malta was a number of streets. Right? If it is postman A who is delivering to 10 streets, the postcode was those 10 streets. Nowadays, I believe that certain streets have two different postcodes. So I don't know exactly how the system works nowadays, but at the time, it necessitated for us, it needed customization. We asked the developers, the suppliers, to customize the way that we entered our addresses. Okay, but extensive customization is something that you need to be aware of. Nowadays, many of these ERPs have what they call APIs, Application Program Interfaces. So you can build satellite systems, other processes outside the ERP, but tag on to the ERP. Right? You have some facility to update the database as well, to add to the database tables and fields. Right? And then through the APIs, you can update existing fields in the database and any new fields that you add on. Now, the benefits of ERPs, first of all, better and faster communication of information. We don't need to go asking around each department, do you have this information? Do you have that information? Right? And then they will pass it on to you on a CD or send it by email or whatever. That information is already available. It is in a central database, so when it is updated at one point, that update will be visible at all points. Improve decision making. We are using a single integrated data repository. So everybody is working, singing off the same hymn sheet. We don't have redundant data. We don't have data discrepancies. We don't have some department saying, no, my data is the correct data. Doesn't match yours, but yours is wrong. Ours is the right data. So here we have a single integrated data repository, which will then translate into better decision making. Stocking inventory only with what is needed to fulfill existing orders. We have much better inventory control, so we don't need to overstock with all the problems of overstocking, and obviously we will not be understocked. We shouldn't be understocked, because if we are understocked, that is going to have an effect on our production. We might lose sales because we are not producing enough. An ERP will give us a uniform organization. Look at this from the eyes of a multinational company. If a company has a number of branches, a number of offices in different countries, and each branch or each office is allowed to get its own information system, there is going to be lack of standardization. If you send one person from one country to another, he will need to learn how to use the information system that is being used in that office. Now, with an enterprise resource planning system, if we implement the same ERP throughout the whole organization, then we don't have to worry about different geographical locations. Everyone is using the same system. Everyone is using the same processes. So it makes flexibility much higher. If you send people from one country to another, they are going to use the same ERP that they used initially in their first location. So they don't need any retraining. We have efficient operations and customer-driven processes. The processes are integrated so that we can give a quicker reply to customer requests. And this diagram shows, right, we've got at the center, we've got our ERP with business processes, and we have those four functions: finance and accounting, sales and marketing, human resources, manufacturing and production. They are all feeding information into the system and taking information from the system. Now, at each end, And we have our vendors that cross organizational boundaries, and likewise at the other end we have customers that cross organizational boundaries. And we are getting information from vendors and customers, and we can also pass information to customers and to vendors. Again, I mentioned here vendor managed inventory. So the vendor can access part of our information here. Obviously, we're not going to give the vendor full access to our database. But if the vendor can see our stock holdings, our order book, things like that, the vendor can plan his production to satisfy our requirements. Again, a diagram where we have our ERP software here with a central database and a number of different modules linked to it. Right? Engineering, sales management, accounting, shipping and delivery, inventory management, purchase management. Right? So these are all different modules that are linked to the same database. Now, as I said, an ERP will normally have supply chain management and customer relationship management. Let me see CRM here. Funnily enough, I can't see CRM here, but anyway, right, as any ERP will include supply chain management and customer relationship management, so you don't need to buy another package, another ERP in order to do supply chain management or to do customer relationship management. Now, supply chain management is managing the supply chain. The supply chain is a network of organizations and business processes that takes us from the purchase of the raw materials right through the whole process of production and sales and distribution to the final customer. So you can see here our manufacturing. This is our company. These are our suppliers. And our suppliers will have their own suppliers. And those suppliers will have their own suppliers. And this is, if you remember the term, the upstream in the value stream. And we are here in the middle of the stream. Upstream, we have our suppliers. Downstream, we have our sales channels, distributors, retailers, and customers. Okay, now the same way that our suppliers will have multiple suppliers and they will have their own suppliers, at the other end also our distributors will have multiple retailers and retailers will have multiple customers. Now when we talk about suppliers, we call the immediate suppliers, the suppliers who supply us, they are known as tier 1 suppliers. Their suppliers are known as tier 2 suppliers, and their suppliers are known as tier 3 suppliers. Now, obviously, these tier 3 suppliers might have other suppliers themselves. So, no, you will be tier 4, tier 5, whatever. Right? So, you can see how far the network can stretch in both ways. So, supply chain management refers to the close linkage and coordination of activities that are involved in buying, making, and moving a product. So getting our supplies, there's a whole chain until those supplies reach us, and then when we manufacture the goods, there is a whole chain until they reach the end consumer. Again, this shows that we are here in the middle, the manufacturer. We have a number of suppliers, they have their tier 2 suppliers, they have their tier 3 suppliers, which is the upstream. And then the downstream, we have our distributors who will have a number of retailers who will have the end shoppers. So supply chain management is an inter-organization system because it links us to both ends of the extremities of our organization. Suppliers at one end, customers at the other end. It manages relationship with suppliers to ensure that we have adequate stocks of raw materials and also products because we need to manufacture and have enough products to sell to satisfy demand, the market demand, but on the other hand, not have surplus products that could be left on the shelf because we can't sell them. Because otherwise, we either have to sell them at a discount, so we reduce our profit on them, or if they expire, we have to throw them away, so we are making a loss rather than making a profit. And with supply chain management, we ensure that products and services reach customers effectively and efficiently. Our supply chain management system may include other components, like a transport management system, especially if we are getting our raw materials, our components from abroad. Right? So we need to manage transport, we need to make sure that the shipments arrive on time for us to use them in manufacturing. And we also need to have warehouse management systems, especially if we are using certain techniques like first in, first out. We have to make sure that first in is really first out. If we are going to use a batch of raw materials or a batch of components, right, they are the oldest batch of raw materials or of components that we had received. Our supply chain systems help us get information about what is available, what is the available inventory, what do we have in stock. And when we compare that to what we have forecast to sell, right, for how many weeks is that stock going to last? We have 500 units. Are they going to last 3 weeks, 4 weeks, 10 weeks? And by knowing when that stock is going to run out, we can plan production of the next batch. Now, when we plan production of the next batch, we need to know whether we have enough raw materials to produce the next batch. Because if we don't have enough raw material, we need to order that raw material. And with supply chain systems, we also get information about when ordered material will arrive. Hopefully it will arrive on time for manufacturing. And when more material is needed based on schedules and sales forecasts. At Marsovino, we had a very good system, right, that looked at the forecast for the next 10 weeks compared to current holdings of each product and planned production, right, for each product in the next 10 weeks. And obviously checking whether we had enough raw material to do that production, and where there was lacking or raw material was going to go low, make raw material orders for replenishment of raw materials. So this information will help us take action, first of all, to determine future requirements. That should be future requirements, not requirements future. Generate new orders, send orders to suppliers, obtain commitment dates for likely receipt, because we need to make sure that we receive those raw materials in time for our production plans, and then verify that ordered material actually arrives, and linked to that, there will be quality assurance on the material that we are receiving. This is an example of a supply chain. Our company is here, right? These are our internal functions, and you can see that here, this is a company like Benna, right? That it bottles and packs milk products. So looking at the upstream, right, our suppliers, the tier 1 suppliers will be a dairy farm or dairy farms who are going to supply us with milk, cardboard container manufacturers, label companies, and plastic container manufacturers. Now those suppliers need to get supplies from their own suppliers. The dairy farm needs to buy feed for cows. The cardboard manufacturer needs to buy cardboard. The plastic container manufacturer needs to buy chemicals from a chemical plant. Again, those tier 2 suppliers might have their own tier 3 suppliers. For example, the paper mill will need to order wood from a lumber company. Now, once we have packaged the products, we sell them to retail grocers, to retail outlets who are going to sell them to the end customer. So this is going to be the downstream part of the supply chain. At the other end of the scale, we have customer relationship management. Now, why the supply chain is from start to finish, from suppliers to end customers, customer relationship management is just the customer-facing part. And so with customer relationship management, we take care of planning, controlling and scheduling pre-sales and post-sales activities. Pre-sales activities, collecting orders. Post-sales activities, making sure that those orders are manufactured, if we are manufacturing to order, they are delivered, they are paid for, and any complaints that customers have, any problems that customers have with our service, with our products, and we can collect those complaints, we can act on those complaints. So with a CRM, we collect data about customer interactions, complaints, service calls, repeat sales, and website activity. Service calls, there could be certain products that need to be serviced regularly. Fire extinguishers, for example. Fire extinguishers need to be serviced, I think every year, every couple of years. Now, most companies, most clients, if we are selling fire extinguishers, most clients will not diarize what the next service date is for each fire extinguisher. So if we have a good customer relationship management system, we can keep service dates, we can remind customers that their fire extinguishers are due for service. So we can send them an email, we can send them a message, look, you have a batch of 10 fire extinguishers that need to be serviced next month. When is it convenient to send an engineer over to service them, to send a technician to service them? We are giving customers that added service. They don't have to remember the service dates for their products, for their extinguishers. We are doing that for them. And repeat sales. What are customers buying repeatedly? What are the most popular products with these customers? And that is important because if we are going to come up with a new product, right, and we look at our customer base and we say, okay, this product is very similar to this other product. Now, who are the major customers of this other product? Because they would be the people who are most likely to buy the new product that we are going to come out with. And so, through customer relationship management, we get a lot of valuable information that will help us in our marketing. The CRM will help in creating and targeting marketing campaigns and promotions. If we know with sales that sales are going down in a particular customer category, then we can focus on that customer category and have a marketing campaign that is aimed at that particular customer category rather than aimed at our whole customer base. Now, with a CRM, we can identify customers who cost little to attract and to keep. They are normally the customers who give us the greatest revenue. So we need to retain these profitable customers. It can cost up to 6 times as much to acquire a new customer than to keep an old customer. It doesn't mean that we do not have make efforts to increase our customer base. Obviously, we always want to increase our customer base, especially if we can entice a top customer away from one of our competitors. But we have to be careful that it doesn't happen the other way around. We have to make sure that we keep our top customers, our most profitable customers, as much as possible. Now we can extend CRM to our business partners. If we have resellers, and Go, for example, have or used to have a number of resellers throughout the island. I don't know whether they still use that concept. But these resellers were given access to part of the CRM, part of the data. and it is called partner relationship management. Right? It uses the same data, tools, and systems as the CRM. And that is a win-win situation because the partners have all the information about their customers. They don't have information about all the customer base of the company, but the customers that they had contacted for the organization, that they had managed to get on board, they have access to the information of those customers. But those customers could go and buy directly from Go now, but the original person, right, the original agent who had the customer on board has access to that information as well. And this diagram, okay, it might look a bit cluttered up, but you can see that we have a CRM there at the center. It is used by all the different departments, a call center, a marketing department, sales department, customer support. And right, we have links with our customers who can communicate in a number of ways with us and with our system. And right, the whole idea is to have customer satisfaction, to build customer satisfaction. And obviously to build internal knowledge, internal information about all our customers that will help us in increasing our sales and in making sure that our customers are satisfied with our products and services. Now, the fourth type of enterprise system is a knowledge management system. Now, with the other three types of enterprise applications that we have seen, right, they are mostly dealing with information, making information available to whoever needs it. Here we are going a step further. You remember when we started off in the initial weeks when we had that data, information, and knowledge? Right? Data giving context becomes information, and then when we build upon information, we increase our knowledge. So a knowledge management system will collect all the relevant knowledge and expertise within the company. But this is very, very difficult to do because knowledge exists in people's minds. It is what we call tacit knowledge. People have acquired that knowledge, and it is very difficult to share that knowledge. It is not encoded somewhere. If I have gained knowledge, my experience in my number of years with a company, that experience is up in my mind. It may not be recorded anywhere. So a knowledge management system will link the company to, first of all, make that tacit knowledge explicit. Record that knowledge so that that knowledge is not vested in one person. That knowledge is available to a number of people. And it also links the company to external sources of knowledge. Now, these are some characteristics of knowledge. First of all, knowledge is a corporate asset. If I have gained knowledge about a particular customer, about a particular process, about a particular product, I have done that during my working hours. I have done that when I have been paid to accumulate that knowledge. So knowledge is a corporate asset, and it needs to be shared as much as possible within the organization. Knowledge is intangible. We can't touch knowledge. As I said, it is tacit, it is hidden, it is stored in people's minds, mind maps, things like that. Right? So knowledge can't be touched, it's intangible. It requires organizational resources to transform data into information and then into knowledge. And that is why it is a corporate asset, because that knowledge has been acquired through the use of organizational resources. The value of knowledge increases as more people share it, what we call the network effect. If I can share my knowledge, I'm sharing my knowledge with 9 people. So there is a network effect. You are learning from my experience. You are learning from my knowledge. And so part of that knowledge now is no longer tacit. It is no longer hidden in my mind. It is being shared out. Knowledge has different forms. It can be tacit, hidden, or explicit, codified and stored. And that is why knowledge management systems, the main objective of a knowledge management system is to make tacit knowledge, turn that into explicit knowledge. It involves knowing how to follow procedures and also knowing why, not just when, things happen. This is called causality. It's not just knowing something has happened, but knowing why has it happened. What are the possible causes for it to have happened? Because by knowing why it has happened, we can identify a solution to what has happened. The advantages of a knowledge management system are some of the advantages. We share valuable organization and information. We don't need to reinvent the wheel, so we reduce redundant work. Let's give you an example. A customer phones up, he has a problem with a product, and he is passed on to a technical person, to a technician or an engineer. The engineer spends an hour and identifies what the problem is. Customer is happy, the engineer goes back to what he was doing before. 10 minutes later, another customer phones up with the same problem. And he is passed on to a different engineer. We don't know that engineer A has solved customer A's problem, and now customer B has the same problem. And the call has been passed to engineer B. He doesn't know what engineer A has done. So he spends an hour to identify what the problem is and to resolve that problem. So he has reinvented the wheel. Right? We have produced redundant work. He has spent an hour for nothing. We have a very rude expression in Maltese, I'm not going to repeat it. So if we share this valuable organization and information, we become more efficient. It will reduce training time for new employees. If there is a knowledge management system, a new employee can tap into this knowledge management system and it will reduce his training time. We retain intellectual property after the employee leaves. In most cases, you have people who have worked with the organization for 40 years. Right? Their first job since leaving school, right? And they retire right, after 45 years, whatever, with the same company. Can you imagine the knowledge that they have amassed? Now that knowledge is going to be lost. That intellectual property is going to be lost when the employee leaves. It could be that the employee resigns because he's taking on another job. And it could be that, unfortunately, that employee is hit by a bus when he leaves work. So by having a knowledge management system, we can retain that knowledge, we can retain that intellectual property. Now, there are different types of knowledge management systems. There are enterprise-wide knowledge management systems. These are knowledge repositories that can be shared by all staff. Examples are structured documents and unstructured email. Right? So these documents, right, if they are in repositories, right, they will embody, they will have a lot of knowledge in them, and they can be shared by all staff. Knowledge network systems, they link experts in different subject areas. We can't be experts in all subject areas, but if we know who the experts in particular subject areas are within our organization and sometimes even outside our organization, if we have a good knowledge network system, then we can link these experts together for particular projects. For example, if for a project we need people we need an architect, we need a notary, we need a designer. And there isn't one person who has all this knowledge. Probably if there is a person who has all this knowledge, he's a master, jack of all trades, master of none. But having a knowledge network system can point us to the right people that we can employ, that we can use. It facilitates collaboration among employees. Right? So these employees coming from different subject areas with different expertise can collaborate much better, much more efficiently. Then we have intelligent techniques. They provide expert judgment based on facts. Remember when I mentioned expert systems and decision support systems, I got an example with a general practitioner who is faced by a patient who has a number of symptoms, and the general practitioner can't identify what malady the patient has. So he can tap into an expert system which will lead him through the symptoms that the patient has, and he can identify the actual malady that the patient is suffering from. Now, some examples of knowledge management systems: a feedback database. Now, a good example is a call center database with potential problems and solutions. We had a very good feedback database at Go. They still have it. And the idea here is that when a customer phones up with an issue, with a problem, the call center clerk checks the database, checks the knowledge base to see whether that problem had manifested itself before and whether it has been or it had been resolved. If it has been resolved already, if it has already been identified and resolved, then the call center clerk can lead the customer through a solution. Now, obviously, there are a lot of advantages to that. First of all, the customer is served immediately. If the call center clerk can identify the resolution, right, what needs to be done, then that customer, in one telephone call, is going to have his problem solved. The second advantage is that we are not utilizing an engineer's time, and engineers are paid much higher than call center clerks. And engineers can carry on with their more important work rather than having to stop from a particular project, for example, in order to identify a problem that a customer has had. So this type of feedback database is very, very important because it has advantages for everybody, for the customer, for the organization, for the engineer himself. The engineer might say, I've already solved this plenty of times. This is the way that you need resolving. Now, another example of a knowledge management system is shared project files, where we have a repository of documents and everybody is updating documents and adding documents to the repository. Obviously, the repository will not allow two people to update the same document at the same time. If someone has taken a document out of the repository in edit mode, then the document is logged and can only be taken out in read mode by everybody else. Similarly, research files, so a research group can share findings between themselves, and document image processing system is an example of a knowledge management system. Is there a question, someone? Because with document imaging, instead of having just one copy of a document that has to pass through several people, we can record that document. We can scan and record that document at one central point, and it is accessible by anybody, by everybody who needs to work on that document. Now, there's a difference between knowledge management systems and knowledge work systems, KMS and KWS. Knowledge management systems enable knowledge to be captured and shared. Knowledge work systems enable people with specific knowledge to practice specific skills. For example, technical designers with CAD, architects with CAD, doctors, right? That particular problem domain that I mentioned before. Because these are knowledge workers, people who need extensive specific knowledge. So it's different from having a knowledge management system. Any questions so far?
No, sir, thank you.
Okay, shall we have a short break? 5 minutes?
Why not?
Okay.
I make it 5 to 7, so let's say 7. We start 7 o'clock. Okay.
Thanks. Who's having coffee? I'm boiling the kettle.
No sugar for me, please.
Oh,
Ask something quickly.
ma nasibx li sama Floyd, ara tittajjax fil-ċet fil-kas.
Sorry, Floyd, li lisa sejt?
It was me, actually.
Okay, Gary.
Kan sa tik bil-Malti naħseb għax.
Again.
Għabda ħarri xi tajjeb Aleksandru. Qed nipprova nikklassifika l-knowledge working system sewa. Biex issa xi tip ta' add-on ma' information system in ġenerali, jew hekk tagħmilx jekk tistax jew tagħmilx sens li tkun entità individwali weħed.
Stand-alone. ħafna drabi tkun stand-alone. In a way, tagħmel sens li jekk forsi tillinkja ma' central database. Imma problematika għax anke l-mod kif knowledge management system tkun strutturata mhux bil-fors it's the structure of a database. Mhux bil-fors formali daqshekk jekk qed tifhimni.
Ija, fimtek.
Normalment it is stand-alone.
Għax fil-fatt iktar ma għanzajna fil-slide iktar bdejt nara li per-eżempju kien hemm l-eżempju ta' riċerkaturi li bija jaqsmu. Għed tmur li għandek xi ħaġa sistema ta' kumpanija bħal database kif qed kien fej ġistet taħżem fiha.
U ġo kumpanija għandek ħafna tipi ta' knowledge differenti.
Eżatt, as opposed to xi ħaġa speċifika.
La xejn diffiċli biex tintegra eżatt.
Okay, thanks.
Okay, is my coffee ready? Who was making coffee?
Yep.
It? Okay, are you all back from your coffee drinking, smoking?
Yes.
Okay, I'm going to carry on then. Right. Any questions on enterprise applications? The 4 types of enterprise applications that we have seen. Enterprise resource planning systems, supply chain management, customer relationship management, knowledge management systems. You're all happy with those? Okay, I don't hear
Yes.
I don't hear any no's, so I take it to be yeses. Right, now we're going to have a look at how application software is procured. We've been speaking about information systems, mentioning different types of systems, huge systems like ERPs. So how is this procured? Software doesn't grow on trees. Right? So someone needs to write software. All software has to be written. Now we'll be looking at the software development life cycle in the next module, SMC 11342 in January. I think most of you will be with me on that module. We'll probably lose a couple of people, but most of you will still be with me. And coding is one of the tasks in the development life cycle. Now we code by using programming languages. And programming languages are people-centric. Programming languages are languages that are understood by people. They are not understood by computers. Contrary to what many people think, computers are stupid. They can only read zeros and ones. Obviously, they need to be led by our programs. Now, we can't write in zeros and ones because although programs are stored within a computer in the memory as zeros and ones, if we have to write all our programs into zeros and ones, it is going to send us crazy. I had experience of one type of machine. It was not a fully fledged computer. It was called a visible record computer, a VRC, an NCR machine, an old NCR machine. And we used to feed in the program on a huge paper, a huge piece of paper. I think it was more than a tree size, and it had a number of rectangles, a number of boxes. And filling in a box meant it was a 1, and leaving a box blank meant it was a 0. And we had to translate all our commands into machine language by filling in these boxes with a special type of pencil. Right? So you can imagine, I think we had about 128 rows with about 12 columns each. So you can imagine if you get to the 128th row and you fill in one of the wrong columns, right, you have to tear it up and start all over again. But thankfully that was very many years ago. Right? So quite a bad experience. All right, it was a useful experience in a way, but it was a very laborious way of programming a machine. Now, programming languages are understood by people. However, they need to be translated to machine-readable format, to this zeros and one pattern. And we do this in one of two ways, either by using a compiler or an interpreter. Now, the difference between a compiler and an interpreter, basically they do the same thing. They translate a programming language into machine-readable language. The difference is that with a compiler, we translate that once, and every time that we use the program, we use the compiled program, what we call the object program. And the non-compiled program is a source program. So we translate the source into object, and we translate it once by a compiler using a compiler, and every time we need to run that program, we run the object program. We only need to recompile when we change the source program. With an interpreter, we have to translate the program, the source program, every time we use it. Right? The object that we create is lost when we finish that program. So next time round, if we need to rerun that program, we have to interpret, right, and recreate the object from scratch. So you can see that a compiler is much more effective and efficient than an interpreter. Another thing is that the packages that we buy are the compiled version packages, the object versions. Obviously, a supplier is not going to give us the source, right? So it is not going to be interpreted every time that we need to run it, because if the supplier gives us the source, he loses control over that source. And suppliers, especially if we go to a third-party software house, right, suppliers obviously will want to keep the source code under their own control. Because if we need any changes to that source code, then the supplier can basically charge us whatever he wants, because he has us under his control. Now, these are different ways of acquiring business information systems. First of all, we can have a custom system development. The system written to our specific requirements. We also call this tailor-made. In the old times, right, we used to have to buy cloth and go to a tailor to produce a suit for us. We take all the measurements and then we will tailor it, and after a couple of weeks the suit will be ready, or you go for the first trial and then we will finish it. So this was the same concept, tailor-made, made specifically to your requirements. So custom build development, custom system development is this tailor making of systems. Now this was the concept up to some 15, perhaps 20 years ago, where companies wanted their developers to develop systems specifically for their requirements. Now, the reason for this, or the two main reasons for this, were first of all because a number of companies thought that their processes were the best processes on earth, that they had competitive advantage because they had more efficient processes than their competitors. So they wanted to capture those processes from a manual environment into a computer system. The second reason was because of resistance to change. The more we change the way people work, the more they're going to resist change. So by trying to keep systems, right, as close to the manual systems that users were used to, then that softened a bit the blow, right, or the problems of resistance to change. I was going to say another thing, I forgot what it was. I remember it. Okay. Now, obviously, if our processes were not that efficient, by automating those processes, were basically automating inefficiency. All right, so that wasn't always a very good idea. So with custom system development, we still have custom system development, mind you, right? Because certain applications are so specific, certain applications are so unique that we need to have them built tailor-made for us. Now there are two ways of procuring these custom development. We can develop them in-house if we have our own in-house development staff, or we can outsource them to a software house. Another way is to buy application packages off the shelf. Now this has become much more common nowadays, not just with the small run-of-the-mill packages like payroll, like accounting, for example, but also with, as we have just seen, enterprise resource planning systems. And the concept here is that these ERPs have been developed by people who have huge amounts of experience in the industry, and they are based on best practices within the industry. So now the concept is we change our processes to get them to mimic these best practice processes rather than automate inefficiency. Now with buying application packages off the shelf, we can buy standard packages and configurable packages. Standard packages normally are the entry-level packages, the lower-level packages that you have to accept as they are. Configurable packages are more high-level, high-value packages like ERPs, like that. We have already seen that they can be configured in a way that the company wants to use them. Other ways of procuring software is to go to application service providers. Now this is the concept of buying software as a service. Especially smaller companies can't afford the licenses for certain packages like SAS, like Oracle Financials, etc. and for other ERPs, because the licenses for such systems are very, very expensive. And for a small company, it doesn't make economic sense to buy licenses for these huge systems. However, they can tag on to the licenses of an application service provider. The application service provider will have bought a number of licenses from the software manufacturer with the agreement that he can lease them out, rent them out. And so this is the concept of application service providers, cloud computing, for example. Open source software, we'll be talking about this again in more detail, but open source software basically is software that is available free of charge. We can go for end user development. However, this applies to small systems because there are a lot of disadvantages with end user development. I'll be going through advantages and disadvantages of each approach. And then we can have hybrid approaches. Hybrid approaches are a mix of the approaches listed above. For example, we can have a mix of development in-house for custom development and outsourced to a software house. A software house that's part of the system, we develop the other part of the system in-house and then we combine them together. Now to look a bit into more detail into these approaches, right, with custom system development, the advantages are that the software is tailor-made to the business needs. Obviously, as long as the business processes are efficient business processes, then right, having custom system development will give us a very robust system. The disadvantages, however, are that it is expensive. If we are going to develop something for our own use, we are going to foot the entire bill. The development will usually experience delays. We've seen, unfortunately, in our industry, in the software industry, a lot of systems are delivered late and over budget. So that's going to hit the expensive disadvantage and the experience delays disadvantage. When implemented, it will probably have bugs. I can tell you, I can guarantee that it will have bugs. Not probably. Because however much we test a system, when it goes live, then it is where we start having the major problems. Unfortunately, when we test, most of the testing is done by technical people, and technical people are not typical users. And when we test, we find it very, very difficult to try to fathom, right, all the mistakes that users and all the data errors that users are going to inject into the system. It's when we let users loose on the system where we start finding that there are certain bugs that we haven't identified when testing. Even though we do user acceptance testing where we have a number of users who test the system, we will still not identify all the bugs within a system. Another disadvantage is that it depends on the requirements being known and analyzed properly. If we don't know the requirements properly, if we don't know the full requirements, we cannot come up with the right system. Once when I was at Doughty, we developed an order processing system. And after about 3 or 4 weeks that the system had been running happily without much problems, one of the clerks called me and he said, I've got an order that I can't input into the system. So I said, look, I'll come down and see what the problem is. And he showed me an order and I said, you can't input that into the system because the system does not allow for that kind of input, for that kind of order. I said, oh, it's not a good system, it doesn't. I said, look, right, we weren't told that you have that type of order. You were given a number of order types, but that wasn't one of them. I said, but we only have this type of order once in a blue moon. It's a process. But if you have it once in a blue moon, the system needs to be able to accept it anyway. Right? Whatever the frequency. And so I said, look, and he said it's an urgent order. I said, okay, start it off manually. While we amend the system so that then you can input the order into the system retrospectively. Right? So the requirements had not been given to us completely. Right? Sometimes users don't even know what they want out of the system. They might tell you, you're the expert. Yeah, okay, I'm the expert, but you're the domain expert. You know what you want out of the system. You know what the system has to give you. And also, we need to analyze those requirements properly. I am putting the blame here, placing the blame mostly on the user, but sometimes some of the blame, right, can be at our end. If we don't analyze the system properly, then we can't come up with the right system that will cater for those requirements. Now, why do we need to outsource development? As I said at the start, yes?
Can I ask a question, please?
Yes,
on the previous slide, if I may. Essentially, what can be done when it comes to the longevity of the system, meaning that I have worked in places where they would have developed the custom system, it would have cost literally an arm and a leg, but due to market, due to the how the market evolved and the changes, and even changes within the business, the system, it kept on doing its job, but it became more of a hindrance rather than actually help the users who are using it.
Kenny, that is
the next couple of years, basically.
Yeah, that is a problem because when we identify the requirements before we develop the system, it is requirements that apply at that point in time. Now, it is very difficult for someone to say, but in 3 months' time, in 3 years' time, we are going to merge with another company. In 3 years' time, we are going to come up with a new product that has different characteristics than the products we are doing now. a case in point is when VAT law came out in Malta, 1994. The accounting systems that had been developed before 1994 did not cater for VAT. Because we didn't have VAT laws here. When government said VAT is going to be introduced from November 1994, those companies that had developed their own software had to update, enhance that software to cater for VAT. Those companies that had locally written packages had to go to the supplier to say, "Oi, are you going to give us a VAT version? Because we need VAT to run from whatever, November 94. Those people who had Sage, for example, didn't have a problem because Sage was an English package that already catered for VAT, and luckily enough, our VAT laws mimicked the English VAT laws to the full. So what they did was to set VAT rates to, initially it was 15%. Before VAT, they used to put VAT rate at 0, right? And then when VAT came out, they changed the VAT rate to 15. Right? Now, in many cases, it is very difficult to try to preempt what's going to happen. So, as you said, yes, the longevity of systems. But one of the main attributes of a good system is that it is maintainable. It can be maintained easily because a system, when we go live with a system, it doesn't mean that that system is going to live for 20 years, 30 years without any changes. There are going to be a lot of changes done to it. In fact, many people say that the cost of the system, the cost of maintaining a system, is much higher than the cost of initially developing it.
That I can confirm because I have seen the actual numbers, that is true.
Sometimes, if the system is not that maintainable, if the system is not written so well, sometimes I've known companies who've had to redevelop the systems from scratch. Now, another problem that can arise is if it's a legacy system, if it's a system that was written some years ago with older technology. And you need to amend the system and you no longer have the skill sets within your organization. We used to develop in COBOL way back in the 1960s, 70s, and 80s. There is still a lot of COBOL. There are still a lot of COBOL systems running, but the people who know COBOL are very, very scarce nowadays because it is like Latin or Greek. Nobody learns COBOL nowadays. Nowadays people learn Java, C++, whatever. What the flavors are, you would know better than me. And so yes, this is a problem with the longevity, length of life of a system. But the trick is to make it as maintainable as possible, using modularization, for example, so that you can easily add another module to a system.
I'm actually going to ask you if there is anything, let's say we, the students, end up in a position where we are either going to suggest a new system or develop a new system. There is something that you would, even with not just as a lecturer, but even with your expertise in the field, is there something that we should keep an eye out for? Not just the information that we ask the customer, but should we go the extra step and say, listen, all right, you have requested A, B, and C. However, I can foresee from the knowledge that I have from the industry that you will also need D and E.
Yes. You can prompt them with that. Now, but usually it is the users who will have more knowledge of the industry themselves rather than the technical person.
All right. Okay.
And as I said, it is very, very difficult to try to foretell what is going to happen. Sometimes even we start off, if it's a 2-year project, for example, right? Sometimes you start off with developing the system to current requirements, by the time that the system is developed, it is obsolete. Because processes will have changed. Products might have changed. The company might have merged with another company. All right, so nowadays we use what we call agile development methodologies. So that if the industry is changing at such a fast pace that there are going to be a lot of changes even throughout the development time frame, then we can take those changes more into consideration. Okay, so that is a method of developing, agile development. The other point that I mentioned is to make the system as maintainable as possible. You will be learning about modularization, hopefully, in next year. All right, with software engineering, there's a particular, so I used to teach it, but I no longer teach that. But it's and there are certain concepts like so I forgot what they're, cohesion, and there's another term. Right? Meaning how modules depend on each other, and that a module does more or less just one thing. Alright, so there are tricks in developing systems to make them much more maintainable. Coupling and cohesion, that's the term I wanted. Alright, so there are ways that when we develop, we make systems more maintainable so that they can last longer. The worst thing you mentioned that once you buy the system, it costs an arm and a leg. Sometimes the problem is that it might not cost an arm and a leg when you buy the original system, but if it is done by a software house, by a third party, whenever you need an upgrade, whenever you need a change, right, that will cost an arm and a leg because you are in your supplier's control. Understood?
Yes, thank you very much, sir.
I'll give you an example from my experience. When I was at Marsovin, we used to report all our sales in dozen because all the products were sold in dozen. Either 2 dozen juices, the small packs, they were sold in 2 dozen trays, a tray of 2 dozen packs. The large packs of juice were sold in a tray of 1 dozen. Wines, they were sold in a crate of a dozen. Right? Now, when we started off with the Lovenbrow experience, initially Lovenbrow was sold in 2 dozen crates, a crate of 2 dozen bottles. One day, right, the marketing manager came up to me. He said, from next week, we are going to start selling Lovenbrow in 33 cl bottles, larger bottles. And they said, okay, give us the details. Right? And they were trying to input the details on the system. And he said, we can't input the unit of sale. I said, why? What's the unit of sale? He said, we're going to sell them in crates of 20. I said, but that goes completely against all our reporting and all our input. I said, if we are inputting sales in dozens or 2 dozens, how are you going to input the sale of 1 crate of 20 bottles? Are you going to convert that into dozen? How are we going to do reporting? Are we going to report in dozen? He said, no, we have to report in crates. I said, so we have a problem. In fact, we had held up the launch of these 33 cl bottles by a week. But I said, we have to amend the whole system. Luckily, it was all in-house, so we had full control over it. I said, we have to amend the whole system because we need to change the whole reporting as well. We started reporting in hectoliters for everything. And it took them, right, it took the people quite a long time to get their head around this, reporting in hectoliters rather than in dozens. Because it was totally against what they were used to. And I remember we had, this was on a Thursday evening, right, and they were launching on a Monday. And obviously the marketing manager wasn't that pleased. And we went up to the CEO, to Tony Kassar, and he called a meeting with the people concerned. First of all, he gave them a good rollicking for not telling us beforehand what was happening. Right? And then he said, how long do you think it's going to take you to amend the system? And I said, give us a week and we'll amend the system. He said, I'll give you 2 weeks. But I knew that it was very, very urgent. So I said, no, we'll finish it in a week. He said, but if you're going to promise me that you're finishing it in a week, don't come today week and tell me you need another week. And I put my head on the chopping board. I said, no, we'll finish it in a week. And then I called all the staff. I had a staff of 4. I had 4 very good programmers with me. And I said, look, we need to do this, 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 and that. And we finished it in a week with all testing, etc. But we delayed the launch. And so these things happen. When we started off with the system, which was, about 10 years earlier, 8 years earlier, nobody got an idea in his mind that we might be selling products in crates, not in dozens or 2 dozens, because that was the standard in the industry at the time. But with these 33 CL bottles, and putting 24 in a box would have made it too heavy. And putting 12 didn't work. So they had to issue them in crates of 20. They already had the crates ordered. Right? They had everything planned out. The only thing that they didn't take into consideration was telling those guys up there in IT that we have this requirement. It didn't enter their mind that it needed a system change. And unfortunately, with users, right, for users, sometimes you analyze the system, you analyze the requirements of a system, you go away and start developing it, something changes, and the last thing on the user's mind is to tell those buggers up there, right, that things have changed. So as you said, yes, it affects the longevity of a system. How can we make systems foolproof? We can't, unfortunately. We can try to make them as maintainable as possible, right, and as upgradable as possible, so that if we need to change them, we can change them easily. But it's very difficult to try to preempt what is going to happen, especially nowadays when businesses in every industry, it's it moves so rapidly. Okay, Ken.
Thank you very much. Thank you for sharing that anecdote, Rashid. When you mentioned both the one of the VAT and especially this one, that it changed not just the quantity quantifier, so to speak.
Yeah.
I was actually seeing it as well from an accounting perspective. How the reporting would need changing from top to bottom, because it's not just changing a quantity value from reading from dozens to 20. It's not just that. There's the whole repercussion. Then how are you going to present that information? How you're going to calculate that information? How the information presented will make sense or not?
Exactly. Okay, so everything has to change, because even the forecasts, for example, because we used to do a lot of comparisons of the actual sales against forecasts. Mm-hmm. So then they have to start forecasting in hectoliters as well. Okay, they used to forecast in dozens, and then we had, obviously, we knew the content of each bottle, so a dozen of this particular product is so much hectoliters, and we're going to sell 20 dozen, then it's so much hectoliters. But for them to interpret the reports, it took them quite a long time to understand that. Okay?
Thank you very much, sir.
Right, so we're going to talk about reasons for outsourcing development. Why do we outsource development? Sometimes it's because we either don't have IS staff or limited IS staff, or we don't have the required skills. Our staff could be overworked. We could be working on another system already, and suddenly another system that is very important crops up. So we can't handle it, so we need to outsource it. Cost and quality. Funnily enough, sometimes it costs less to outsource than to do it in-house. Now you might say, but how can that be if the outsourcer wants to make a profit? Because the supplier has economies of scale. He has perhaps more efficient ways of working. He has more efficient and more trained staff. He might want our customers. I said sometimes buying the initial system might not be that expensive, but we have to be very careful when it comes to enhancements, because then we don't have the source code. The source code is owned by the supplier, and we can only go to that particular supplier to get changes. So that supplier can ask us an arm and a leg, as Kenneth put it, for any changes. Especially if we offshore outsourcing, if we outsource to offshore companies. They could have lower salaries in developing countries. For example, in India, they have a very good software industry. The UK company that did the billing for Go, Cerillion, they have right, a subsidiary in India that does all their development, because the salaries there are much, much lower. The quality, suppliers core, it's the supplier's core business, so he might have more qualified staff. There are contractual obligations. Internally, sometimes it is very difficult to try to keep your people to work to certain standards. All right, you can take disciplinary action perhaps, but you can't really find them. But by outsourcing, there are contractual obligations. You have to meet quality standards, for example. You have to meet deadlines. Internally, it is very, very difficult to impose deadlines, especially if you are always asking your staff, look, stop working on that system because we have something more urgent. So, going to miss a deadline, but it's not their problem. By outsourcing, if there is a deadline, the contractor can't come and say, look, I've taken a government tender now, and I'm going to shelve your project for 3 months. I'm going to say, oh, of course you won't. Especially if there is a late payment, a late delivery penalty. You are committed to deliver by a certain date. I expect you to deliver by that date. And there could be a service level agreement. And we may also outsource because we need to concentrate on core competencies. We have a system that is going to achieve more efficiency in our primary activities. Remember the primary activities in Porter's value chain? So we are going to concentrate on that because that is our primary activities. That is where, right, efficiency or the greater profitability is going to be. And we are going to give out something like perhaps a personnel system, a payroll system, although we should be buying those as packages. Now, I'll give you an example also from my working experience with outsourcing. When I was at Parsons, we wanted to develop a satellite system for our agents to place their orders. And internally, we had a huge debate because unfortunately, certain people wanted to develop, and they had decided that Microsoft Access was the main development tool, and I was totally against Microsoft Access. Access is a fantastic tool, but it is a fantastic user tool. It is not a developer's tool. And I was dead against using Microsoft Access. And I wanted to use the same language that we had in our ERP, something called Gembase. And there were people who were against using Gembase. So we reached a compromise. We said, okay, we'll develop, at that time it was 1997, 1998, Visual Basic was the flavor of the month. So we agreed that we will neither use Gembase nor Microsoft Access, but we use Visual Basic. Now, we didn't have any Visual Basic skills in-house, so we agreed, we made an agreement with a local company, a local software house, who developed the Visual Basic, and that agreement included training 2 of our programmers in Visual Basic for 2 weeks, and then our 2 programmers were attached to this company for a period of 2 months to develop the software. And the software was developed by our 2 programmers and 2 of their experienced Visual Basic programmers. So after a 2-week training period, our programmers were not really fully fledged Visual Basic programmers, but by spending 2 months with 2 experienced programmers, they got a lot of skills on board. And the agreement was that when the system was ready, they will support the system for the first 3 months, giving us hot support, and then we take over the system with the source code so that we take complete control over the system. And that worked very well. So we outsourced the training and the development of the system, and then we took over the maintenance of the system because we had 2 programmers who were fully fledged Visual Basic programmers. And the supplier didn't have control over us when we wanted changes. When we wanted changes, we had full control over the source. So we could change as much as we wanted without additional costs. Now, advantages and disadvantages of outsourcing. The advantages, again, software is tailor-made. It frees up internal resources. It may be cheaper. Normally, it is better quality. And we have access to more expertise when we outsource. Obviously, we choose the right software house, right? They will have more expertise normally than we would have in-house. Right? So it gives us some learning opportunities as well. Disadvantages, basically the same disadvantages as we had with internal custom build, still relatively expensive. When implemented, it will still have bugs. It still depends on requirements being known and analyzed properly. But here we have also loss of control and loss of skills. Application packages. We have many information systems that are similar across companies, especially those information systems that cater for the support activities, the secondary activities in the portal value chain. Remember those 4 support activities: infrastructure, research and development, procurement, and human resource management. And many companies use payroll systems are very similar, point of sale systems are very similar, even accounting systems. You find a lot of packages for accounting systems. Now, normally software houses develop such systems initially for 1 or 2 or 3 clients. So the functionality of those systems will initially be a bit limited. Eventually, they add features to support a wider range of customers. Now, these packages will contain a number of modules. That is why they are called application packages. For example, an accounting package. I will have sales ledger, purchase ledger, general ledger, asset register. Right? So, and people might buy different ledgers. When I was involved with a software house, we had a customer. We had an accounting package. We had a customer who wanted a purchase ledger system standalone on its own. I think he wanted to fiddle with VAT. but that was his problem. Packages can be tried and evaluated. In many cases, we can download an evaluation version of a package, which will be a limited version. You can have a limited number of transactions, a limited number of customers, and then we can pay for the license and get the full version. Buying a package reduces the time delay because the system is already operational, is already there, it is already documented and maintained. Basically, you can just load it and go. It reduces the amount of development needed. Now, these type of packages do not provide competitive advantage. Right? The point of sale system, payroll system. Like normally, point of sale systems then will have some additional functionality like loyalty points, things like that. But for example, a payroll system doesn't really give a competitive advantage. Now, the configurable packages, the further up the scale packages like enterprise resource planning systems will obviously be more cater for more functionality, but again, it is very difficult for that package to provide competitive advantage unless you use it in a better way than your competitors. Now, the advantages, buying software off the shelf, software already exists and you can try the version, available immediately. It is of a high quality because the initial bugs are already fixed. The customers who have bought that package before you have identified all the bugs or most of the bugs that are in that package. So most of them will be fixed already. Relatively low price and there is support available. The disadvantage are that you depend on the supplier. What happens if the supplier goes bust? If the supplier goes out of business? Now, if it is a smaller type of package, you buy another one, cut your losses. But if it is an ERP, for example, then if your supplier goes bust, then you have a big problem. One way of going around that is to have what we call an escrow agreement. There is a third party involved and you agree with the supplier that he deposits a copy of the source code with the third party. So that if the supplier goes bust, at least you can have access to the source code and you either maintain it internally or find another company to maintain it for you. It may be inflexible because it may not cater 100% to your needs. You may find that certain processes you still need to do manually. Application service providers, as I mentioned before, it's a pay-per-use. You utilize the licenses that the application service provider has bought or is paying for. And if you use the software, if you use the service for 40 hours in a month, you pay for that. If you use it for 60, you pay for 60, etc., etc. So a good example is cloud computing, and here we see the concept of software as a service. The advantages: it is attractive for smaller companies because they save on capital investment. They don't need to buy a lot of hardware. Obviously, you need your PCs in order to access the cloud, but you don't need your own servers. You don't need a data center. You don't need to train staff to maintain it because all the maintenance is done by the application service provider. Copying of data, backups, things like that. They are administered by your service provider. You spend less on hardware and it is very quick to implement because the system is already there. Disadvantages: again, you depend on your supplier, may be inflexible and may not cater 100% to your needs, and there are security risks. Because again, you depend on your supplier, you don't know what security features your supplier has. He is going to hold all your data. So there is a question mark on whether that data is 100% secure. What if your application service provider is hacked and your data is accessed? Open source software, this is developed by a community and is distributed under an open license. It means that that license is free. Okay, so it is free to use, modify, and distribute. However, you may not sell it on, obviously. You're going to get it for free. You can't make a profit out of it. And developers and users have to abide by certain rules. If you make changes, for example, those changes, the new software has to be made available for others. Agents and developers may charge for additional services, but not for the software itself. And if you get open source software, but you have no idea how you're going to implement it, then you can find an implementer, and that implementer may charge for his additional services. The advantages, again, they are attractive for smaller companies because it's inexpensive. There is support available, and because it already exists, it is very quick to implement. Disadvantages, again, it may be inflexible because you have to use what there is. It may not cater 100% to your company's needs, and it may suffer from reliability, depending on who had developed the software in the first place. How reliable is key. How will bugs get corrected? Although there is a community that takes care of this software, and you might find that you might not get a very easy solution to a problem that you have found. And it may have security risks. Something that you are downloading for free, it might have a Trojan horse in it. It might have a rogue program linked to it. Now, end user development, we see quite a lot of software systems developed by people who don't have formal software engineering training and don't use formal processes. And so the employees, the software end users, tailor their own software, develop their own software to support their work. And they can use things like Microsoft Access, which I mentioned is a fantastic user tool. I know people who have used Excel spreadsheets, accountants. All of you are accountants, you love Excel. And Excel is very, very powerful. You can build an application using Excel. Normally, there is no official support and maintenance given by the IES department. Sometimes these systems become crucial for business operation. Right? It's something that a user has done for himself, but it has become so important for operation that if that user leaves, if the person who developed that in the first place leaves, then you could be in trouble. The advantages are that shortened lead times, right? The user can develop his own system in a very quick way. It's a good fit to needs and culture. There aren't the problems involved here that we need to understand what the user wants, that the user needs to explain what he wants. The user knows what he wants, so it's a good fit to his needs. Users acquire skills. Next time round, they're going to build a better system. It frees up IS time. The IS people can carry on playing Noughts and Crosses and Battleship, developing high-end systems, the core systems, without spending time to develop these small systems. Disadvantages, because users have lack of development skills, then normally these systems are of a poor quality. Again, they may create information silos. A user might be capturing information. He knows that he has that information, but the rest of the company doesn't know that that information exists within the organization. There is no centralized control, so no programming standards. Everybody programs the way he knows how, the way he thinks. Are backups being taken? Again, so we are at the mercy of the users themselves to back up their data. That data would be very, very important, and we know how users are with backups. So normally we ask them to put the data on a server so that that data can be backed up frequently with the other data on the server. They could lead to duplication of effort. 2, 3 people in the same department might have similar needs, and they might all develop their own system, which will be systems that will be more or less similar. So there's duplication of effort. Security. How secure is that system? Especially nowadays with things like general data protection, GDPR, and if they are collecting data about individuals, that data, we need to make sure that that data is secure. Another disadvantage is that we are creating single points of failure. The person who has developed that system becomes a single point of failure. If he leaves the organization, does anybody else know what went into that system? If there needs maintenance to that system, how that system is going to maintain? Do we need to start from scratch? Now this matrix here is just a combination of what I have been talking about, right? The different acquisition options, and they are compared against some factors there, like delivery time, cost, the quality as far as bugs are concerned, and the quality as far as it fits business needs are concerned. I'm going to skip this. We'll come back to it after you finish your Anki assignment. Now, these are some criteria for successful applications. Whatever approach we use to build our applications, we need to make sure that these applications are successful. And what makes applications successful? First of all, how aligned are they with business goals and needs? How much do they really help the organization? Do they provide the right information to the right people at the right time? Because if we don't provide the right information to the right people at the right time, then that application is not a success. Do they provide appropriate levels of security? Are we sure that only the people who need access to that information do access that information? Maintainability and adaptability. Kenneth, I come back to maintainability. It's a successful application if it is maintainable and adaptable. If when we need to change something, when we need to add something to the system, we cannot do it because the system is very difficult to maintain, then it is not a successful application. We know that a system is going to need a lot of maintenance, a lot of changes throughout its lifetime. There's no escaping from it. It happens. It's a fact of life. So we need to make sure that they are maintainable and adaptable. User-friendly and easy to use. If a system is not easy to use, if it is not user-friendly, users will not use it. Now here we are talking about systems that are out there like e-commerce systems. Internet systems, you can force staff to use them. If you need to enter an order, that's the only system. You have to enter your order in that system. There's no other way. But if we are talking about systems that are used by external people, if they are not easy to use, if they are not user-friendly, people are not going to use them. If someone wants to buy something from us and finds our e-commerce site too laborious, too difficult to use, then he's going to say, I'm not going to buy from these people. I'll find another supplier, someone who can give me a better user interface. And making the best use of information technology. It could be a fantastic system, but based on old technology, or technology that is going to die a natural death. So the longevity of that system cannot be guaranteed. Okay, I'm going to run for another about 5 minutes if you don't mind, but I'd like to finish this set of slides. There isn't much to talk about here because we're going to talk about the IS department. Basically, it is responsible for maintaining the company's infrastructure. It is headed by the Chief Information Officer. Nowadays, we've got used to the American way of calling these chief officers, CIO, CFO, CEO, etc. And the chief information officer needs business background as well as IS expertise. It is not enough for the CIO to be an expert in information